Hello, fans of trig. I would like you to look at reference angles tonight or this weekend. Is the Friday night version 9:25, and you may be watching it Saturday or Sunday. Please take notes and let's talk about them. Reference angles. I'll start my timer. There we go. Reference angles are sort of like reference books. So let's go see if we can find a reference book in my house. Walking along. Oh, a bookshelf. A blurry bookshelf. Alright, that's clear. What would look like a good reference book? Here we find, pleasant reading, The History of Mathematics. Truly a reference book that you have been longing to look into. So, look at this book. I had to read this book to get a degree so I could teach you guys. So, a reference book is a book that will help you learn something difficult and make it pleasant. So that's what reference angles are going to do for us. They're going to help us find sine, cosine, and tangent of angles that are larger. So we're going to take something that's simple and apply it to something that is larger and see how it can help us. Let's just define what a reference angle is, and then we'll figure out how to use them. So let's write down this definition. Write it with me. A reference angle is a positive acute angle. When I say positive acute, acute means less than 90 degrees. We all know what a right angle looks like. So acute angles are less than 90 degrees, and they are acute. So we have an acute angle less than 90 degrees, and that's always for a reference angle. Positive and acute angle formed between let's see, let's get that in the screen. Formed between, come back. All right, see if I can get it in here. A reference angle is a positive acute angle formed between the terminal side of an angle. Remember the terminal side we've met previously this year. The terminal side of, we'll call it angle theta, and the x-axis. Alright, so let's put a picture to those words. Positive acute angle formed between the terminal side of theta, or the angle, and the x-axis. So it's going to look slightly different in each quadrant. So we'll go around and do each quadrant. We'll do it in general, and then we'll do a specific one for each. So in quadrant 1, we have a situation where you have an angle something like that, and the reference angle is going to be the acute angle formed between this is the terminal side and the x-axis. So it's going to be this value right there. And I don't mean that we're going in the negative direction, but I'm saying the amount of degrees that exists between the terminal side and the x-axis. So that is going to be a positive angle, but I'm talking about this difference. The reason I draw the arrow downward is because I'm going toward the x-axis every time. So we get to color on this one. So I want you to color in the reference angle. And so in the first quadrant, you notice the angle and the reference angle are the same. So quadrant 1 angles are their own reference angles. So it's not going to be very difficult, but I'll do an example. Let's say the angle is 32 degrees. 32 degrees is from here to here. Well, the reference angle is from the terminal side to the x-axis, which is also 32 degrees. And I don't care about the direction here. I just want to indicate the positive distance between these two lines. So, all right, let's do quadrant 2. Quadrant 1 was easy peasy. Quadrant 2. Let's look at that. So here, the initial side is here, and we rotate around until we get in quadrant 2. It looks like I'm calling that quadrant 2. Alright, so I'll put that over here so it's clearer. Quadrant 2 is over here, so I'm going to put the terminal side here. So I start it here, and I rotate it, and it doesn't show up. So I started here and rotate it over to there in the second quadrant. The reference angle, again, is the positive acute angle formed between this terminal side and the x-axis. So it's this value right here. So color it in. This is the reference angle. And the reference angle is calculated in this case. If we know theta is from here to here, we can get from here to here by taking all the way straight across theta. So I'm going to say theta reference, the reference angle, is going to be 180 degrees. That would be from here to here minus our angle. Or if we're using radians, it'd be pi minus theta to get the reference angle in the second quadrant. All right, example. So the example I'm going to do for quadrant 2 is 5 pi over 6. So when we're figuring out where 5 pi over 6 is, we remember this is pi over 2, which in 6 is we multiply the top and bottom by 3, we get 3/6 pi. And we know over here is pi radians, which is 6/6 pi. So you can confirm that between 3/6 pi and 6/6 pi, 5/6 pi must be. Alright, so we have the terminal side. So I've come from here to there to find 5 pi over 6. So let me move it out of the way. Alright, put it over here where it's more meaningful. So I've rotated 5/6 pi radians across. Now where's the reference angle? It's always the acute angle between the terminal side, which I've darkened, and the x-axis. So it's right there. How do I figure out what its value is? The reference angle is going to be pi radians, which would be straight across, so 180 degrees. But since we're in radians on this example, I'm going to use pi radians minus 5 pi over 6. And that will give us this darkened region. So this is 6/6 pi minus 5/6 pi, so the reference angle is, not Q, I'm trying to do reference angle theta. Reference angle is 1/6 pi, which I'm going to write as pi over 6. Alright, so that's quadrant 2 example. Quadrant 3. I bet you can figure this one out without my help. We're going to draw an angle whose terminal side is in the third quadrant. So we're going to start here as usual and go over to here. So our angle's terminal side is right there. Can you, before I do, obey these words and color in the reference angle, which is the positive acute angle found between the terminal side of theta and the x-axis. So here's our theta. It starts here and ends here. Where is that acute angle? The difference between that terminal side and the x-axis is right here. Did you color it in correctly before I did? All right, and mathematically, how would we get this value? In the third quadrant, we know from here to here, and to get this distance, we're going to subtract pi, or 180 degrees. So we're going to take the angle and subtract pi radians, or 180 degrees. So either one of these will give us the reference angle. Let's see an example in quadrant 3. I'll do another radian one. Let's do 13 pi over 12. So we've got to find that. And once again, I'm going to start using fractions. This is 0 radians. This is pi over 2. But when I work in twelfths this time, I multiply the top and bottom by 6. 6 pi over 12. This is pi radians, or 12 twelfths pi. And this one was 3 pi over 2. So to change that to 12s, 6 over 6 again, I get 18 pi over, what am I multiplying by? 6, sorry, 12, 18 pi over 12. So you can see that between 12 twelfths pi and 18 twelfths pi is 13 twelfths pi. So maybe about right there. So my angle is in the third quadrant. And the reference angle, coloring it in, is right here, is found by taking the angle itself, 13 twelfths pi, and subtracting 12 twelfths pi. And I'm going to get pi, 1/12 pi, or pi over 12. And that is my reference angle. And these actually will become useful. I'm just giving you some training right now. And the last part, I think I'm going to shut down this part and go ahead and do the fourth one on the next segment. So see you on part 2.